Hello, everyone. This is Joshua Brunk, and I will be recording my group's final project called Pathify. Pathify allows you to find the most efficient route between your starting location and the most optimal property that matches your characteristics in our database. Alrighty, well, let's get started. We have our front end with React, and we have our server running as well. Let me quickly restart it so we can see the outputs as it runs. Alrighty. So let me put in some coordinates. Alrighty, here's our starting coordinates. And let's select our algorithm. And let's click a target price. Let's do 80,000 maybe. Yeah, sounds good. All right. Now this process will take a while. Dijkstra's usually takes about 40 to 50 seconds. And A star takes about 20 to 30 seconds. So while we wait, we can quickly go over some of the architecture decisions that we made. So let's go over here. As you can see, this is the input has come in. Now we can take a look at the main. First of all, one thing I'd like to comment on is learning the Crow library. The Crow library is an open source, simple, server such as something like Flask in Python. It's actually written similar to Flask, so we can use things that we would know from Flask to make it very nice to write. Basically, we call /process and specify if we're doing Dijkstra's or if we're doing A star, and we run the corresponding function with the parameters that are submitted. So that works great. And yeah, another interesting thing about our implementation is that we used geolocation as well, or reverse geocoding, as it's called, to find the cities or the city names of the locations that you enter. So we can also tell you your city. You'll notice here, our responses just came back in. We have a complete breakdown of the time it takes and the memory as well. But you can see we have the city as well for the paths. Yeah, and so that's great. Now we're running A star as well, and A star returned much faster, of course. And we have a complete breakdown of the memory and a complete breakdown of the time as well. Great. All right, so everything is back, everything is sent, and the response is back to the front end. Great. And you'll notice we have a great map. In our using the Google Maps API, our front end is able to easily show both satellite and map, and we can keep zooming in here. Alrighty, so our starting coordinates were there, and here's our ending coordinates. The most optimal direction or connection between our two properties. Now this is how long it took for our Dijkstra's algorithm, and this is how long it took for our A star, and of course this is the memory difference. You'll notice A star saving 20 seconds for only 40,000 bytes nowadays is great. So I would pick A star any day, but both have their uses and both are really useful. So yeah, this is our project, and we're really proud of it. Thank you very much. Feel free to try it out, try different longitudes and latitudes. Yeah, everyone, really quick wanted to mention some additional features that were left out of the original video. So, of course, Kai on the front end allows us to view any of the Google Street Map views. So you can actually take a little journey around and see the exact properties that were on your charts. So of course, here we go. Come down here and see some of the properties that you chose. So feel free to also try this out for yourself.